Okay, I'm doing the BC Practice Exam Question 1, the one that's A through G. So this is so exciting. Okay, so 25 minutes. So let's see, I have my screen recorder. So we'll see how long it takes me to. 5 minutes to upload. I'm not uploading. Okay, the continuous function, let's see what I see. It says the continuous function f is defined on the closed interval -2 to 5. Okay. And consists of 2 line segments and a quarter circle. Okay, so this one is a circle. Okay, looks like radius 3, quarter circle. Okay, I can see that. Half circle right here, if I need it. Okay, centered at 0.53. Okay, as shown in the figure above. The function is given by this. Okay, cool. So if I want to take the derivative, I'm going to use Leibniz. Okay, average rate of change. Okay, average rate of change. So there's 2 ways to think about it. The way that I usually think about it is 1 over b minus a, integral of the rate of change. Now it says of g, so that would be the rate of change of g, and I can use x or t or whatever letter I want to use, and then that's dx, I like x, and then that's from a to b. So this is average rate of change. Now that would be the antiderivative would be g of x, and you're substituting in a and b, and that's still over b minus a. So some of you might recognize average rate of change as algebra slope. So this would be another way to do it, which would be algebra slope. Okay, so I'm thinking, which way do I want to do it? Let's see, g prime of x, I'm going to use Leibniz, so that's f of x times the derivative. Remember, you substitute this in, multiply it by the derivative of the upper bound, subtract, substitute the bottom number in, and multiply it by the derivative of the bottom bound. So this is f of x, and this is g prime of x equals. So do I want to do 2 integrals? So basically this version right here, so let me use a highlighter, but this version right here has me having to find 2 integrals by plugging it into x. So I'm thinking that maybe I like the other version better. So my version that I usually use, personally, is I like this one, and then I work it out to the other one if I need it. And the reason I'm going to do that, let me get back to my pen. Okay, and let me change, we'll just keep it at blue, is because I can write 1 over b minus a, which is, what, 5 minus -2, integral from -2 to 5. G prime is f of x. And then that's the integral of the graph. So that's what I'm thinking. I think that's better. So that looks kind of funny that that's what it is, but I took the derivative. It's f of x. Average rate of change, I would substitute this in here. Okay, so this is correct. So it's the integral of the graph. So the integral of the graph would be the signed area. So I need the signed area from -2. Okay, so I need this area right here. I need this area right here, but it's below, so it counts as negative. Now technically that's 1 and that's 1, and those are triangles, and so they're equal triangles, so those are actually going to cancel out. And this looks like it's a half. I'm not sure if it's a half. Let's check. Rise 2, run 1. So this is a half right here. Oh, but this is also 0. Look at this. So that blue area, let me change colors for you. So it seems like that one's not the eraser. Oh, the eraser's right here in this app. Okay, I have too many apps that I use. This is positive area. This is positive area. And then we're going all the way to 5. So this is positive area. Right, and then this is positive area. Okay, and then this area here that I'm putting in the purple, oops, not right there, the area between the equation or the graph and the x-axis is negative area. So I'm going to say that this set of areas right here is 0 because they're equal. This set of areas is 0 because it's equal. And then I can find the area of the rest. So I think that I'm going to put equals 0 plus 0 plus, okay, so this would be, I probably, in showing my work, To me, that's kind of a little bit of space, so it'd be nice if, you know, you're writing it on a separate piece of paper. But basically, maybe I'll just draw the picture here. Plus, right? Okay, so that would be the trapezoid. This is 1 high, this is 3 high, and this is 1 wide. Or you could do a square and a triangle. Okay, so that would be 1/2 times the width, which is 1, and then 1 plus 3, which is base 1 plus base 2. I call it height 1 plus height 2 because I'm in a kind of a sideways trapezoid. So this would be the formula. And then plus, that would be the area of the square minus the area of the semicircle. And this is 3, this is 3. So the area of the square would be 3 times 3, and then minus the area of the quarter circle, sorry, not a semicircle. So 1/4 pi r squared. So pi r squared. Okay, so this would be, and in BC usually you don't have to simplify, but 4, that's 2 plus 9 minus 1/4 times 9 pi. It's just hard for me not to simplify. 11 minus 9/4 pi. I probably typed that into the calculator just to make sure that I'm still positive, but I should be positive based on those values. 3 times 2 is 6. Yeah, I think it's positive, but I would just double check. Okay, so that would be, and this is because this is the square, and then I'm subtracting out the quarter circle. So I'm subtracting out this part of it to get the rest, to get the little part that's remaining. Okay, and then that is the trapezoid. So that would be the answer to A. Let's see how I'm doing for time. 6 minutes, 54 seconds. Okay, so this one, substitute in. Probably I'm going to be using L'Hopital's rule is what I'm thinking. So substitute in carefully f prime of -1 minus -1. So f of 1 minus 1 over f prime of -1 plus 1. And f of 1 is the y value of the f graph, which is shown at 1. So over to the x graph, I go to 1, and the y value is 1 minus 1. Okay, so that's 0. So this is looking probably like L'Hopital. F prime of -1 is the slope, and the slope at -1 would be over here. So let me trace it. I'm going to trace it with green. At -1, it looks like the slope is down 1, right 1. So that would be -1, and then plus 1, which is also 0. Okay, so it is an example of L'Hopital, but you would need to first get the 0 over 0 to use L'Hopital. I would label it in IB. They give you a point for labeling it. In BC, we don't know, so might as well. So L'Hopital limit as x approaches -1. Derivative of this would be f prime of x squared times 2x plus the derivative of x, which is 1. And in the denominator, the derivative of f prime is f double prime, so f double prime of x minus 1. And then I'm going to substitute in again, so this is f prime of 1 times -2 plus 1 divided by f double prime of -1 minus 1. Definitely, I think I like a different piece of paper for this. Okay, so f prime of 1. F prime of 1 is the slope at 1. So let me trace this in green so we can see it. So the slope at 1, which is right here, would be rise to run 1. I can just use algebra slope on that. So this would be 2 over 1. So in the numerator, this would be -3. And in the denominator, f double prime of -1. Okay, now usually you don't know the actual values of f double prime, so I'm thinking it might have to be 0. Because I don't know what other number I would know for sure f double prime was unless I wrote myself an equation. So f double prime of -1 is right here. Okay, so what I probably would say is that in that section, f double prime is a line. So I think I would write that somewhere. So I would put at x equals -1, f double prime, well, not f double prime, but I would write f of x is a line, mx plus b. That's a little b. So that would be f prime is m, and f double prime is 0. So this would be 0. So 0 minus 1, so this would be +3 altogether. Yeah, definitely writing on a separate piece of paper and not in the section seems like that's going to be a good idea. Okay, I'm at 10 minutes. C, for -2 to 5, find all values of x for which the graph has a point of inflection. Now, graph of which? Graph of G has a point of inflection, so I need G double prime of x equals question mark. Now, I know that G prime of x equals f of x, so that means G double prime of x equals f prime of x. And then I'm going to make a number line. My number line, I'm going to put walls on them. -2 to 5, so I don't go outside of the region. So -2 to 5. I put them at the ends. And one side I like to label G double prime, and the other side I like to label f prime. Now, if I'm looking at the picture itself, that's f. So f to an f prime graph, I'm going to write over here, would be the slope of the f prime graph. Okay, so the slope of the f prime graph starts negative. Specifically, it's -1, but it starts negative, and it goes negative until where it's sharp. Now, sharp or 0 or discontinuous all need to be on the number line. So that is at x equals 0. And then the slope of the f graph is positive until 2. X equals 2. And then the slope is undefined there, so I would need that. Even if it was increasing and increasing again, if it's sharp, I need to put it on the number line. If it's going to be, if I'm talking about slope. And then the slope is negative. Okay, now that was the slope of f prime, but this would be the concavity of G. So concavity of G would be concave down, concave up, concave down, and it says G has a point of inflection. So I would say at x equals 0 and x equals 2, G double prime of x equals f prime of x changes signs. And it says for what x values. So I guess I probably would put maybe a more complete sentence. So I would say points of inflection. And I don't like to abbreviate because I don't know if they'll understand my abbreviation. At. So I think I would write this. Make sure your number line is labeled. Okay, C, evaluate. Oh, I can't read it. Okay, you have to be kind of careful of this. Now, this looks like a U sub. Looks kind of weird. I'm going to rewrite it. So this is 2 to 4. Okay, so let's see. So 6 minus 2x du equals -2 dx. This is rarely in a free response question. Looks like a multiple choice question, actually. So it's kind of cool that multiple choice practice is still, lucky we did some multiple choice practice. So this is f prime of u, and that's du over -2. And then I need to change the bounds. These are x bounds, and then I need to change them to u bounds, or I need to take the antiderivative and then later change it to u. I'm thinking that's going to confuse me. So I think what I'm going to do in this case is I'm going to do -1/2. I'm going to bring it out in the front. I'm bringing this out in the front. I think I'm going to change them to u numbers. Okay, so this is f prime of u du. And then how do we change them to u numbers? So let me show you. Let me remind you how to do this. Oh, and this is the end of this page. Okay, so let me change colors so you could see better. So over here we have u equals, right here, u equals 6 minus x. So that would be if x equals 4, then u equals 6 minus 2 times 4. So that's 6 minus 8, which is -2. So this would be u equals -2. And then the other one would be for x equals 2. So that's 6 minus 2 times 2 for u. So u equals 6 minus 4, which is 2. And then don't switch them at the moment unless we have to. They are what they are. They land where they land. Okay, the antiderivative of f prime is f from 2 to -2, -1/2. So that would be negative, I'll write it below, -1/2 f of -2 minus -1/2 f of 2. Okay. Okay. And f of -2 means the y value of the f graph at -2. So y value of the f graph at -2 is 1. So this is -1/2 times 1 plus 1/2 times f of 2. F of 2, the y value is 3. So that's 3. So that's -1/2 plus 3/2. You don't have to simplify, but I'm just used to simplifying. 2/2, which is 1. Not necessarily recommending simplifying. You could leave it like this right here. You could leave it like this, and you would get full credit. Okay, same thing on this one. You could leave it, this is in the problem above, you could leave it like that, and you would get full credit. Okay, so these are the answers here in my green at the moment. Okay, but they are going to be looking at your work. Okay, looks good. So we're at 15 minutes, and we have 25 minutes to do the problem and 5 minutes to upload. Okay, so we'll see how we're going to do on the rest. Okay, they're going to give me a new problem. Okay, looks totally different. They gave me another graph, but it's just totally different. I know they're calling it the same question, but it's different. Okay, so this one right here says hn of 0. So that's h, oops, change to, okay. And the key here on this test, don't panic. However much time you have, just use it to do well. And what you know is going to shine through, okay? So just do the best that you can. So this is h up to of 0 equals 3. Well, that really means h double prime of 0 equals 3. That's what that means, right? Because this is the third derivative at 0 equals, oh, this seems like a Taylor series. H to the fourth derivative equals 54. Yeah, it seems like a Taylor series where they gave me the values. And then a graph. That's kind of cool. Okay, derivatives of all orders of all real numbers. A portion of the graph is shown. Now, this is h. Okay, so this is h, and then those are h. Oh, that's interesting. So I could find h of 0, which is 3, because it's the y value, and h prime of 0 is the slope. So what's the slope at 0? Well, it's a line. So down... Oh, okay, it says this is the tangent line, because I was about to do the slope of this line here. Okay, but the slope of the line and the slope of the tangent line, the slope of the curve and the slope of the tangent line are the same at that point. So I could use rise over run. So rise over run would be down, it looks like down 2, right 1. So down 2, right 1. Just make sure I have my signs right. Okay, write the third degree, okay, let's keep reading. Of x equals 0. Select derivatives at x equals 0 given in the table. Line tangent is tangent at that. Let's write the third degree Taylor polynomial, so that means I need x to the third, about x equals 0. Okay, so this would be the polynomial would equal h of 0 plus h prime of 0 times x minus 0 to the 1 over 1 factorial plus h double prime of 0, x minus 0 to the 2 over 2 factorial. That's only a second degree. So h triple prime of 0, x minus 0 to the third over 3 factorial. I guess I'll put a subscript of a 3 so they know that it's my third degree polynomial, so that I can put an equal sign. Okay, h of 0 I figured out was 2. H, so it would be minus 2, x over 1 factorial is 1. H double prime is 3, so that's x squared over 2 factorial. H triple prime is negative 23 halves over 3 factorial, x to the third. And you don't have to simplify it, so that would be the answer. Write but do not evaluate an integral expression that gives the volume of the solid when r is rotated around the line y equals negative 2. Okay, y equals negative 2 is down here, negative 2. And I want this region, I'll make a little, I think I'll use verticals. And on the BC test and on the AB test, supposedly there's only disk method. So you don't even have to know shell method. But if it helps you, then you can use that. Okay, so that's going to be the washer method, disk washer method. So that's pi big R squared minus little r squared dx. And then if I'm looking at the picture, I'm going to write this over here. Capital R is y top minus negative 2. And then little r is y bottom minus negative 2. Okay, so capital R would be y top, which is the equation of h, so h of x plus 2. And then little r is y bottom, which is a line, plus 2. So what would that line's equation be? Well, that line's equation, I have the y-intercept, right? So this is y equals mx plus b. So y would be down 2, right 1, negative 2x plus b, which is 3. So negative 2x plus 3. So this would be negative 2x plus 3. Gives write an expression but do not evaluate. I also need to know my bounds. So 0 is my x bound to 1 because I'm using dx's. So this would be pi. Big R would be h of x plus 2 squared minus negative 2x. I guess I'll simplify that and put plus 5 squared. I do have my pi. I have my dx. And then I need my bounds for x. So that would be 0 to 1. And then this is the answer. How am I doing for time? 21 minutes. Okay. Evaluate this where p is greater than 0. So I'm going to just put some samples in. So p is greater than 0. Let's say p was 0. Okay, if p was 0, it would be 1 over x, which is ln. But they're saying it's bigger than 0. So that means it could be like 0.1, 1.1. It could be 1 over, say it's 2, say it's 3. Okay. Okay. So I just wanted to look at some samples for myself, just so I could see it. And this is not included. Okay, so how would I do these? I would go x to the negative 2, x to the negative 3. I would need to do a limit. So limit as b approaches infinity of 1 to b. And then I would call this x to the negative p minus 1 dx. I can add a power, negative p minus 1 plus 1, right? Plus 1 divided by, and then you add the negative p minus 1 plus 1, the exponent, and then I want to go from 1 to b, limit as b approaches infinity. Okay, and remember, you don't have to get 100%. This is the BC test. If you get like a 70%, you get a 5. And who knows with the new test, so you don't have to get everything right. So don't panic if you're not getting everything right. Okay, limit as b approaches infinity. This would be negative p at the bottom. And at the top, it's x to the negative p from 1 to b. So this is 1 over x to the p negative from 1 to b. Limit as b approaches infinity. So this would be 1 over negative, I'm substituting these in for x. Sometimes you forget. So I'm substituting that in for x, so that's b to the p times p plus, minus a negative, 1 over 1 to the p times p, limit as b approaches infinity. Okay, so b approaches infinity to the p is positive, so this goes to 0, and the answer is 1 over, okay, 1 to the p is really 1, not 1.1, so it's just regular 1, so 1 to any power is 1, so that would be p, and then I think that's it. Okay, now I'm the teacher, so I should be finishing in time, right? So I barely finished in time, so if you're not finishing in time, don't panic. Okay, you don't have to get it all right. Okay, you don't have to get it all right. Actually, this highlighting is a bad idea. So let me unhighlight. Okay, well, at least it's a bad idea in the color that it's in. Okay, so let me highlight here. I wouldn't highlight if you're sending it to IB because I think AP, I think it would be more difficult. Okay, so there we go. And that was it for this question. Okay, I definitely have some pieces of paper available so you could spread out. Okay? Wow, so that's the end of that one. 25 minutes. I'm going to stop it. So class, it looks like I made a mistake on one of them. I was checking my answers, but I messed up on A because this 1/7 here in the front, I forgot to put it in my answer. So that's why I put it in red pen. Anyway, so not bad. I got the other ones right. But anyway, I forgot my 1/7. So hopefully you guys had your 1/7. I'll add this to the end of the other video so that it'll look joint. And then you'll just see this at the end where I'm making my error. Anyway, so very strange. And I can't find the answer to the third one, so I'm still looking. So we'll see, just so we can check mine. I definitely don't think that I'm perfect, so I might have made an error on the other one too. So I have 2 sets of solutions in. We'll see about the third.